In example 3, we begin with two rational functions, each of which has the same common denominator, but that means we need to start off by identifying restricted values in those two functions. In this case, we can't have 9x minus 4 equal to 0, telling us that regardless of what our final expressions are, x cannot be equal to 4/9. So we need to make sure we add that restriction to the domain for every function. In part A, we want the sum of these two functions, meaning we're going to take 4x plus 9 over 9x minus 4 and add 8x over 9x minus 4. Since these two functions have the same common denominator, we can simply combine this into a single rational function. All over that common denominator of 9x minus 4, and then add together, combine any like terms in the numerator. That will give us 12x plus 9 over 9x minus 4. 9x minus 4 can't be equal to 0, but that was the same restriction that we had in the original function, so our domain would have one restricted value, which is that x cannot be equal to 4 over 9. In part B, we're going to subtract these two functions. Where again they have that same common denominator, meaning we can go ahead and merge this into one rational function and combine like terms. This is going to give us negative 4x plus 9 over 9x minus 4. And we still have that same domain restriction that x cannot be equal to 4/9. In part C, we're going to take the product of these two rational functions. There's nothing that will cancel here, so we can simply multiply straight across and distribute. We'll take 8x times that quantity 4x plus 9 to give us 32x squared plus 72x. And expanding everything out in the denominator will give us 81x squared minus 72x plus 16. Our denominator factors is 9x minus 4 times 9x minus 4, since we already have that. So that tells us we still have that same restricted value, that x cannot equal 4/9. In part D, we're going to take the quotient of these two functions, meaning we're going to take 4x plus 9 over 9x minus 4 divided by that second function, 8x over 9x minus 4. Our first step will be to rewrite this as a multiplication problem by taking the reciprocal of that second function. When we do that, we'll see 9x minus 4 in both the numerator and denominator, meaning we can cancel those factors, leaving us with 4x plus 9 over 8x. We need to make sure this resulting function doesn't have a 0 in the denominator, meaning x cannot be equal to 0. And then even though it's not specific for this final function, since 4/9 was a restricted value in the original two functions, we also have to include that restriction that x can't be equal to 4/9.